Hello children, now let us talk about trigonometric functions. First, a quick recap of what we have learned in our previous classes. Measurement of angles. There are two systems to measure angles. First, English system and second, circular system. In English system, angles are measured in degree, minute and second. 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. In circular system, angles are measured in radian. One full circle is equivalent to 2 pi radians, and that is also equal to 360 degrees. So 360 degrees is equal to 2 pi radians, or 180 degree is equal to pi radian. Trigonometric ratios. There are 6 trigonometric ratios defined: sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. In a right angle triangle, triangle ABC, angle B is equal to 90 degrees and angle A is equal to theta. Then sin theta is equal to BC upon AC. Cos theta is equal to AB upon AC. Tan theta is equal to BC upon AB. Cot theta is equal to AB upon BC. Sec theta is equal to AC upon AB. Cosec theta is equal to AC upon BC. Also, sin theta and cosec theta are opposite to each other. Cos theta and sec theta are opposite to each other. Tan theta and cot theta are opposite to each other. That means sin theta is equal to 1 upon cosec theta, or cosec theta is equal to 1 upon sin theta. Cos theta is equal to 1 upon sec theta, or sec theta is equal to 1 upon cos theta. Tan theta is equal to 1 upon cot theta, or cot theta is equal to 1 upon tan theta. Basic trigonometric identities. Sin theta into cosec theta is equal to 1, or sin theta is equal to 1 upon cosec theta, or cosec theta is equal to 1 upon sin theta. Cos theta into sec theta is equal to 1, or cos theta is equal to 1 upon sec theta, or sec theta is equal to 1 upon cos theta. Tan theta into cot theta is equal to 1, or tan theta is equal to 1 upon cot theta, or cot theta is equal to 1 upon tan theta. Tan theta is equal to sin theta upon cos theta. Cot theta is equal to cos theta upon sin theta. Sin square theta plus cos square theta is equal to 1, or sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. Sec square theta is equal to 1 plus tan square theta, or sec square theta minus tan square theta is equal to 1. Sec theta plus tan theta is equal to 1 upon sec theta minus tan theta, or sec theta minus tan theta is equal to 1 upon sec theta plus tan theta. Cosec square theta is equal to 1 plus cot square theta, or cosec square theta minus cot square theta is equal to 1. Cosec theta plus cot theta is equal to 1 upon cosec theta minus cot theta, or cosec theta minus cot theta is equal to 1 upon cosec theta plus cot theta. Science of trigonometric functions in different quadrants. These are 4 quadrants numbered as first quadrant, second quadrant, third quadrant and fourth quadrant. This is 0 degree or 360 degree line. This is 90 degree line, this is 180 degree line and this is 270 degree line. This angle is in first quadrant. Anti-clockwise is supposed to be positive direction. In first quadrant, all trigonometric ratios will have positive value. Sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta all will have positive value, where theta lies between 0 to 90 degrees. In second quadrant, only sin theta and cosec theta will have positive values, where theta lies between 90 degrees to 180 degrees. In third quadrant, only tan theta and cot theta will have positive values, where theta lies between 180 degrees to 270 degrees. In fourth quadrant, only cos theta and sec theta will have positive values, where theta lies between 270 degrees to 360 degrees. Now let us see how the values of trigonometric ratios change when the angles are in different quadrants. If the angle is theta or 90 minus theta, angle is in first quadrant. In this table, in last column, angle is theta and in first column, angle is 90 minus theta. So in these two columns, angle is in first quadrant. If the angle is 90 plus theta or 180 minus theta, then the angle is in second quadrant. In this column, angle is 90 plus theta, and in this column, angle is 180 minus theta. So in these two columns, angle is in second quadrant. If the angle is 180 plus theta or 270 minus theta, then the angle is in third quadrant. In this column, angle is 180 plus theta, and in this column, angle is 270 minus theta. So in these two columns, angle is in third quadrant. If the angle is 270 plus theta or 360 minus theta, then the angle is in fourth quadrant. In this column, angle is 270 plus theta, and in this column, angle is 360 minus theta. So in these two columns, angle is in fourth quadrant. There is no need to memorize this table if you can keep in mind these three important points. Point number 1. First, figure out in which quadrant the angle is. Second, as per the quadrant, value will be positive or negative as per this rule. In first quadrant, all the trigonometric ratios will be positive. In second quadrant, only sine and cosec will be positive. In third quadrant, only tan and cot will be positive. And in fourth quadrant, only cos and sec will be positive. Point number 3. For 90 minus theta, 90 plus theta, 270 minus theta, and 270 plus theta, means where 90 and 270 is involved, sine will change to cos, cos will change to sine, tan will change to cot, cot will change to tan, sec will change to cosec, and cosec will change to sec. For example, let's see here, sine 90 minus theta, so sine will change to cos. Let's say tan 90 minus theta, so tan will change to cot. Tan 90 plus theta, so tan will change to cot. Similarly, for 270, you can see sine 270 minus theta, so sine will change to cos. 270 plus theta, let's say cot 270 plus theta, so cot will change to tan. For 180 minus theta, 180 plus theta, 360 minus theta, and 360 plus theta, means where 180 or 360 is involved, there will not be any change. Means sine will remain sine, cos will remain cos, tan will remain tan, cot will remain cot, sec will remain sec, and cosec will remain cosec. In this table, values of some standard angles are given. You need to memorize them as you are going to frequently use them. Now let us see the graphs of trigonometric functions. Sin x, cos x, tan x, cot x, sec x, and cosec x. Let us see the graph of y is equal to sin x. Its maximum value is 1 and minimum value is minus 1. At x equal to 0, it passes through origin. At x equal to pi by 2, its value is maximum, that is 1. At x equal to 3 pi by 2, its value is minimum, that is minus 1. It's similar on the negative side of x. Y is equal to cos x. Its maximum value is 1 and minimum value is minus 1. At x equal to 0, its value is maximum, and at x equal to pi, its value is minimum. It's similar on the negative side of x. Y is equal to tan x. Its minimum value is minus infinity and maximum value is plus infinity. At x equal to 0, it passes through origin. At x equal to pi by 2, its value is plus infinity. And at x equal to minus pi by 2, its value is minus infinity. You may study the graph of cot x, sec x, and cosec x. Now let us see the trigonometric ratio of sum and difference of two angles. Suppose two angles are angle A and angle B. Then sin A plus B is given by sin A cos B plus cos A sin B. Sin A minus B is equal to sin A cos B minus cos A sin B. Cos A plus B is equal to cos A cos B minus sin A sin B. Cos A minus B is equal to cos A cos B plus sin A sin B. Tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B. Tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. Cot A plus B is equal to cot A cot B minus 1 upon cot B plus cot A. Cot A minus B is equal to cot A cot B plus 1 upon cot B minus cot A. If you multiply sin A plus B and sin A minus B, you will get sin square A minus sin square B, as this is in a plus b into a minus b form. So it will be a square minus b square. If you simplify, you will get sin square a minus sin square b. Similarly, cos a plus b into cos a minus b, you will get the result as cos square a minus sin square b. This also is in a minus b into a plus b form. So it will be a square minus b square. On simplification, you will get this result, cos square a minus sin square b. Similarly, you can try out tan a plus b into tan a minus b and cot a plus b into cot a minus b. These bunch of formulas are frequently used, so you need to memorize them. Trigonometric ratio of sum of three angles, and the three angles are angle A, B and C. Then sin A plus B plus C is equal to sin A cos B cos C plus cos A sin B cos C plus cos A cos B sin C minus sin A sin B sin C. It is easy to memorize as there will be four terms, 1, 2, 3 and 4. Last term will be all three sign and it will be negative. Other three terms will be positive and they will be 1 sin and 2 cos. It will start with sin A, then in second term sin B, in third term sin C. Similarly, cos A plus B plus C is equal to cos A cos B cos C minus cos A sin B sin C minus sin A cos B sin C minus sin A sin B cos C. This also is easy to memorize. There will be four terms, 1, 2, 3 and 4 terms. First term will be positive, other three will be negative. Angles will come in that order, A, B and C. First term will be all cos and other three terms will be 1 cos and 2 sin. It will start with cos A, then cos B, then cos C. Tan A plus B plus C is equal to tan A plus tan B plus tan C minus tan A tan B tan C upon 1 minus tan A tan B minus tan B tan C minus tan C tan A. This is easiest to memorize. Now let us solve few questions based on the formulas we have just seen. First question, if sin x plus y upon sin x minus y is equal to a plus b upon a minus b, then tan x upon tan y is equal to what? By just looking at this, you may guess that we are going to apply componendo and dividendo law, and that is exactly what we are going to do. First, we need to expand them. Sin A plus B is equal to sin A cos B plus cos A sin B, and sin A minus B is equal to sin A cos B minus cos A sin B. Here A is equal to x and B is equal to y. Now you can apply componendo and dividendo law. So numerator plus denominator will come in numerator and numerator minus denominator will come in denominator. Similarly, on the other side, numerator plus denominator will come in numerator and numerator minus denominator will come in denominator. So when you add them, you will get 2 sin x cos y in numerator, and when you subtract them, you will get 2 cos x sin y in denominator. Similarly on the other side. So it will be sin x upon cos x means tan x into cos y upon sin y will be cot y. When cot y comes in denominator, it will be tan y. So tan x upon tan y is equal to a by b. So that is our answer. Second question, if sin theta plus cos theta is equal to root 2 sin theta, then sin theta minus cos theta is equal to what? Given that sin theta plus cos theta is equal to root 2 sin theta, take sin theta to the other side. So root 2 sin theta minus sin theta is equal to cos theta. Take sin theta common in these two terms. So root 2 minus 1 into sin theta is equal to cos theta. Bring cos theta to the left hand side and take root 2 minus 1 to the right hand side. So on the left hand side, sin theta upon cos theta becomes tan theta. So tan theta is equal to 1 upon root 2 minus 1. Now rationalize the denominator. That means multiply numerator and denominator both by conjugate of denominator. So you need to multiply numerator and denominator both by root 2 plus 1. So tan theta becomes root 2 plus 1. Now make a right angle triangle, triangle ABC, in which side BC is root 2 plus 1 and side AB is 1. So that tan theta is equal to root 2 plus 1 upon 1. That is root 2 plus 1. Now applying Pythagoras, you can figure out side AC. So AC comes out to be under root 4 plus 2 root 2. So sin theta will be BC upon AC and cos theta will be AB upon AC. So sin theta minus cos theta is equal to root 2 plus 1 upon root 4 plus 2 root 2 minus 1 upon root 4 plus 2 root 2. Take LCM as root 4 plus 2 root 2. So it is root 2 plus 1 minus 1. Plus 1 minus 1 gets cancelled. So it will be root 2 into 1 upon root 4 plus 2 root 2. This is equal to cos theta. So the answer is root 2 cos theta. Third question, if alpha and beta are two solutions of the equation a tan x plus b sec x is equal to c, then find the values of sin alpha plus beta and cos alpha plus beta. It is given that a tan x plus b sec x is equal to c. Take a tan x to the other side. So it becomes b sec x is equal to c minus a tan x. Now square both the sides. So it becomes b square sec square x is equal to c minus a tan x whole square. Sec square x can be written as 1 plus tan square x. So this becomes a quadratic equation in tan x. Now alpha and beta are given as two solutions, means tan alpha and tan beta will be two roots. So tan alpha plus tan beta will be equal to minus b upon a, and tan alpha tan beta will be equal to c upon a. So tan alpha plus beta is equal to tan alpha plus tan beta upon 1 minus tan alpha tan beta. Value of tan alpha plus tan beta is this, and value of tan alpha into tan beta is this. So tan alpha plus beta comes out to be 2ca upon a square minus c square. Now make a right angle triangle with angle B as 90 degrees and angle A as alpha plus beta. Then side BC is equal to 2CA and side AB is equal to A square minus C square. So that tan alpha plus beta is equal to 2CA upon A square minus C square. Now apply Pythagoras theorem to figure out AC. So AC comes out to be A square plus C square. Now sin alpha plus beta is equal to BC upon AC and cos alpha plus beta is equal to AB upon AC. So this is the answer. Transform the product to sum or difference of two angles. These are products and these are sum or difference of two angles A and B. These four formulas are coming from here. We have already seen the expansion of sin A plus B, sin A minus B, cos A plus B and cos A minus B. Sin A plus B is equal to sin A cos B plus cos A sin B. Sin A minus B is equal to sin A cos B minus cos A sin B. When you do sin A plus B plus sin A minus B plus cos A sin B and minus cos A sin B get cancelled. So sin A cos B plus sin A cos B will give 2 sin A cos B. Similarly, when you do sin A plus B minus sin A minus B, you will get 2 cos A sin B. When you do cos A plus B plus cos A minus B, you will get 2 cos A cos B. When you do cos A minus B minus cos A plus B, you will get 2 sin A sin B. Transform the sum or difference to product of two angles. This is sum or difference and this is product of two angles. These four formulas are coming from here. 2 sin A cos B is equal to sin A plus B plus sin A minus B. Here this is angle A and this is angle B. So when you add them, you will get C. And when you subtract this from this, you will get D. So formula becomes sin C plus sin D is equal to 2 sin C plus D by 2 into cos C minus D by 2. Similarly, you will get other three formulas from these three respectively. You need to memorize all these 8 formulas. Now let us see few questions based on transformation. First question, find the value of sin 3a plus sin a into sin a plus cos 3a minus cos a into cos a. First, we need to expand them. Sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2. Cos c minus cos d is equal to 2 sin c plus d by 2 into sin d minus c by 2. Sin of minus a is equal to minus sin a. So this will become negative. These are two equal terms with opposite signs. So they will cancel each other. Result will be 0. Second question, simplify. Sin a plus sin 3a plus sin 5a plus sin 7a upon cos a plus cos 3a plus cos 5a plus cos 7a. Here we need to pair up terms. If you add 7a to a, it will be 8a. If you add 5a to 3a, it will be 8a. So we need to pair up sin 7a with sin a and sin 5a with sin 3a. So it will be sin 7a plus sin a plus sin 5a plus sin 3a upon cos 7a plus cos a plus cos 5a plus cos 3a. Now we can expand. Sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2. Same formula will be used here. Cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2. Same formula will be used here. So in numerator, it will come as 2 sin 4a cos 3a plus 2 sin 4a cos a upon, in denominator, 2 cos 4a cos 3a plus 2 cos 4a cos a. In numerator, we can take 2 sin 4a as common. So it will come as cos 3a plus cos a in bracket. In denominator, 2 cos 4a can be taken as common. So in bracket, cos 3a plus cos a. These will get cancelled. So answer will be sin 4a upon cos 4a, that is tan 4a. Third question, if sin theta plus sin phi is equal to root 3 times cos phi minus cos theta, then sin 3 theta plus sin 3 phi is equal to. Given that sin theta plus sin phi is equal to root 3 times cos phi minus cos theta. First, we will expand these. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. Cos c minus cos d is equal to 2 sin c plus d by 2 sin d minus c by 2. Take this to left hand side and take 2 sin theta plus phi by 2 as common. So in bracket, it comes out to be cos theta minus phi by 2 minus root 3 sin theta minus phi by 2. And that is equal to 0. So either this is equal to 0 or this is equal to 0. Accordingly, we will consider two cases. First case, when sin theta plus phi by 2 is equal to 0. That means theta plus phi by 2 is equal to 0 or theta is equal to minus phi. So value of sin 3 theta plus sin 3 phi is equal to sin 3. Put the value of theta as minus phi. So sin of minus theta will be equal to minus sin theta. So it will be minus sin 3 phi plus sin 3 phi. That is 0. Second case, when cos theta minus phi by 2 minus root 3 sin theta minus phi by 2 is equal to 0. Multiply and divide by 2. So it comes out to be 2 into 1 by 2 cos theta minus phi by 2 minus root 3 by 2 sin theta minus phi by 2 is equal to 0. 1 by 2 can be written as sin 30 degree. Root 3 by 2 can be written as cos 30 degree. So we can write this as 2 into sin pi by 6 minus theta minus phi by 2 is equal to 0, as sin A cos B minus cos A sin B is equal to sin A minus B. So this part will be equal to 0. So theta is equal to pi by 3 plus phi. So value of sin 3 theta plus sin 3 phi will be sin 3. Put the value of theta as pi by 3 plus phi. So it comes out to be sin pi plus 3 phi plus sin 3 phi. Now sin 180 plus theta is equal to minus sin theta. So it will be minus sin 3 phi plus sin 3 phi. So it will be 0. So in both the cases, value of sine 3 theta plus sine 3 phi is equal to 0. So the answer is 0. Now let us see trigonometric ratios of multiple and submultiple angles. Multiple angles such as 2 theta and 3 theta, and submultiple angles such as theta by 2. First we will see multiple angles. Sin 2 theta is equal to 2 sin theta cos theta. Cos 2 theta is equal to cos square theta minus sin square theta is equal to 2 cos square theta minus 1 is equal to 1 minus 2 sin square theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now trigonometric ratios of submultiple angles. Sin theta is equal to 2 sin theta by 2 cos theta by 2. Cos theta is equal to cos square theta by 2 minus sin square theta by 2 is equal to 2 cos square theta by 2 minus 1 is equal to 1 minus 2 sin square theta by 2 is equal to 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. Tan theta is equal to 2 tan theta by 2 upon 1 minus tan square theta by 2. These formulas are similar to these set of formulas. The only difference is in place of 2 theta, theta is written, and in place of theta, theta by 2 is written. Now let us see few questions based on trigonometric ratio of multiple and submultiple angles. First question, simplify. Under root 2 plus under root 2 plus under root 2 plus 2 cos 8x. Cos 8x can be written as 2 cos square 4x minus 1, as cos 2 theta is equal to 2 cos square theta minus 1. So when you open the bracket, it will be under root 2 plus 4 cos square 4x minus 2. Plus 2 and minus 2 get cancelled. So it will be under root 4 cos square 4x, and that is equal to 2 cos 4x. So now it is equal to under root 2 plus under root 2 plus 2 cos 4x. Now cos 4x can be written as 2 cos square 2x minus 1. Again, using the same formula, cos 2 theta is equal to 2 cos square theta minus 1. So it will become 2 plus 4 cos square 2x minus 2. Again, plus 2 and minus 2 get cancelled. So it will be under root 4 cos square 2x, which is equal to 2 cos 2x. Now this is equal to under root 2 plus 2 cos 2x. Now cos 2x can be written as 2 cos square x minus 1. Using the same formula, cos 2x is equal to 2 cos square x minus 1. So now it becomes under root 2 plus 4 cos square x minus 2. Again, plus 2 and minus 2 get cancelled. So it will be under root 4 cos square x, or equal to 2 cos x. So this can be simplified as 2 cos x. Second question, find the value of sin to power 4 pi by 8 plus sin to power 4 3 pi by 8 plus sin to power 4 5 pi by 8 plus sin to power 4 7 pi by 8. Notice here that 7 pi by 8 can be written as pi minus pi by 8. 5 pi by 8 can be written as pi minus 3 pi by 8. So replace sin to power 4 5 pi by 8 by sin pi minus 3 pi by 8 whole to power 4. And sin to power 4 7 pi by 8 can be written as sin pi minus pi by 8 to power 4. We know that sin pi minus theta is equal to sin theta. Same here. So it can be written as sin to power 4 3 pi by 8, and this can be written as sin to power 4 pi by 8. Now combine this and this and this and this. So 2 can be taken out. In bracket it will come as sin to power 4 pi by 8 plus sin to power 4 3 pi by 8. Now this can be written as sin square pi by 8 whole square, plus this can be written as sin square 3 pi by 8 whole square. Now this can be replaced by 1 minus cos pi by 4 upon 2, as we know that cos 2 theta is equal to 1 minus 2 sin square theta. So 2 sin square theta is equal to 1 minus cos 2 theta, or sin square theta is equal to 1 minus cos 2 theta upon 2. So here theta is equal to pi by 8. So sin square pi by 8 will become 1 minus cos pi by 4 upon 2 as per this formula. And here theta is equal to 3 pi by 8. So sin square 3 pi by 8 can be written as 1 minus cos 3 pi by 4 upon 2. Now we know the value of cos pi by 4. It is 1 upon root 2. We need to simplify cos 3 pi by 4. So cos 3 pi by 4 can be written as cos pi minus pi by 4. We know that cos pi minus theta is equal to minus cos theta. So this minus will become plus. So cos pi by 4 is equal to 1 by root 2. So it can be simplified further to get the value 3 by 2. Third question, simplify root 3 cosec 20 degree minus sec 20 degree. Cosec 20 degree can be written as 1 upon sin 20 degree, and sec 20 degree can be written as 1 upon cos 20 degree. Take sin 20 cos 20 as LCM. So it will be root 3 cos 20 minus sin 20 upon sin 20 cos 20. Now multiply and divide by 2 in numerator. So numerator will become 2 in bracket root 3 by 2 cos 20 minus 1 by 2 sin 20 upon sin 20 cos 20. Root 3 by 2 can be written as sin 60 degrees. 1 by 2 can be written as cos 60 degree. So numerator will become 2 times of sin 60 cos 20 minus cos 60 sin 20. Now this is in the form sin A cos B minus cos A sin B, and that is equal to sin A minus B. So numerator will become 2 times of sin 60 minus 20 degree, and that is equal to sin 40 degree. Sin 40 can be written as 2 sin 20 cos 20, as sin 2 theta is equal to 2 sin theta cos theta. Now sin 20 cos 20 cos 20 get cancelled. So answer will be 2 into 2, that is 4. These two tables show the trigonometric ratios of some typical angles. If you could memorize these values, they will help you solve some typical questions in exams. Otherwise, time will be consumed in deriving these formulas. In some cases, you will not be able to even derive the formula. For example, 18 degree, multiple of 18 degree and 37 degree. So it makes sense to take time to memorize these values. Now let us see how to find out maximum and minimum value of a trigonometric expression. Suppose the trigonometric expression is a cos theta plus b sin theta. Equate that to capital A. So capital A is equal to a cos theta plus b sin theta. Do dA upon d theta and equate that to 0, because we know that at maximum or minimum point, slope of tangent will be equal to 0. That gives tan theta is equal to b by a. Make a right angle triangle, angle B as 90 degrees and angle A as theta. BC is equal to B and AB is equal to A, so that tan theta is equal to B by A. Now apply Pythagoras to figure out AC. That will be equal to under root A square plus B square. So sin theta is equal to B upon under root A square plus B square, and cos theta is equal to A upon under root A square plus B square. Now at maxima, dA upon d theta is equal to 0 and d square A upon d theta square is less than 0. At minima, dA upon d theta is equal to 0 and d square A upon d theta square is greater than 0. Do d square A upon d theta square from here. So you will get minus under root A square plus B square. Now A square plus B square will always be positive because the square of a number is positive. So square root of A square plus B square will also be positive. Outside is negative, so overall it will be negative. So in this case, dA upon d theta is equal to 0 and d square A upon d theta square is negative. So A maximum we can find out from here. A maximum will be A cos theta plus B sin theta. Value of cos theta and sin theta can be put from here to get A maximum is equal to under root A square plus B square. Now let us see various methods to solve trigonometric equations. First, we will see types of solutions. There are three types of solutions and they are principal solution, general solution and particular solution. In principal solution, theta lies between 0 to 2 pi. That means starting at 0, going anti-clockwise and making a full circle, covering all the quadrants once. General solution means solutions for any theta, even if theta is more than 2 pi. Particular solution means solutions in the given interval. Suppose in a question it is given that theta lies between 0 to pi. That means we have to consider only those solutions in which theta is either in first quadrant or in second quadrant. Now let us see general solutions of some trigonometric equations. I have made 4 cases. First case is when sine theta, cos theta, tan theta are equal to 0. In second case, when sine theta, cos theta and tan theta are equal to 1. In third case, sine theta is equal to sine alpha, cos theta is equal to cos alpha, tan theta is equal to tan alpha. And in fourth case, sine square theta is equal to sine square alpha, cos square theta is equal to cos square alpha, tan square theta is equal to tan square alpha. Then these are the general solutions written against them. This is easy to understand. Sine theta is equal to 0 means sine theta is equal to sine 0 or sine pi in 0 to 2 pi. So general solution will be theta is equal to n pi. Cos theta is equal to 0 means cos pi by 2 or cos 3 pi by 2. So general solution will be theta is equal to 2n plus 1 pi by 2. Similarly, we can explain these. Let us understand this one. Sine square theta is equal to sine square alpha. That means general solution is theta is equal to n pi plus minus alpha. Let us prove this. Sine square theta can be written as 1 minus cos 2 theta upon 2. Similarly, sine square alpha can be written as 1 minus cos 2 alpha upon 2. That means cos 2 theta is equal to cos 2 alpha. This matches with this. So general solution is theta is equal to 2n pi plus minus alpha. That means 2 theta is equal to 2n pi plus minus 2 alpha. So theta is equal to n pi plus minus alpha. That is the general solution. Similarly, we can prove this and this also, that the general solution remains same in all three cases, that is theta is equal to n pi plus minus alpha. Now let us see methods to solve trigonometric equations. The ultimate objective is to reduce the given equation in one of the 4 forms, and the forms are sin x equal to 0 or sin x equal to 1 or sin x equal to sin alpha or sin square x equal to sin square alpha. And we know the general solutions in all those cases. Similarly for cos x and tan x as well. First type, equations of the form sin x is equal to sin alpha, cos x is equal to cos alpha, tan x is equal to tan alpha. Let us see this question. 2 sin x plus 1 is equal to 0. We have to solve this trigonometric equation. Sin x is equal to minus 1 by 2, and this can be written as sine of minus 30 degrees or sine of minus pi by 6. Now this is in the form sin theta is equal to sin alpha. So the general solution will be theta is equal to n pi plus minus 1 to power n alpha, where theta is equal to x and alpha is equal to minus pi by 6. Here n is integer. Second type, equations reducible to the forms sin x is equal to sin alpha, cos x is equal to cos alpha, or tan x is equal to tan alpha. Let us see this question. Now we have to solve this trigonometric equation. Sin x plus sin 3x plus sin 5x is equal to 0. We can combine these two. So sin 5x plus sin x plus sin 3x is equal to 0. Now we can expand this as sin c plus sin d, and that is equal to 2 sin c plus d by 2 cos c minus d by 2 plus sin 3x is equal to 0. This becomes 2 sin 3x cos 2x plus sin 3x is equal to 0. Now we can take sin 3x common in these two terms. So it becomes sin 3x in bracket 2 cos 2x plus 1 is equal to 0. That means either sin 3x is equal to 0 or 2 cos 2x plus 1 is equal to 0. Consider first case when sin 3x is equal to 0. Now it is in the form sin theta is equal to 0. So theta is equal to n pi is the general solution. That means 3x is equal to n pi or x is equal to n pi by 3. In second case, if 2 cos 2x plus 1 is equal to 0, that means cos 2x is equal to minus 1 by 2. And minus 1 by 2 in cos form can be written as cos 2 pi by 3. That means it is in the form cos theta is equal to cos alpha. So the general solution is theta is equal to 2n pi plus minus alpha. Here theta is 2x and alpha is 2 pi by 3. So 2x is equal to 2n pi plus minus 2 pi by 3 or x is equal to n pi plus minus pi by 3. Let us see two more questions of this type. Second question, sin 2x plus cos x is equal to 0. So cos x is equal to minus sin 2x. Minus sin 2x in cos form can be written as cos pi by 2 plus 2x. Now it has become cos theta is equal to cos alpha form. So the general solution will be theta is equal to 2n pi plus minus alpha. Here theta is equal to x and alpha is equal to pi by 2 plus 2x. So x is equal to 2n pi plus minus pi by 2 plus 2x. Now we will consider two cases when sign is positive and when sign is negative. When sign is positive, so x is equal to 2n pi plus pi by 2 plus 2x. Now taking 2x to the left hand side. So x minus 2x is equal to 2n pi plus pi by 2. This gives x is equal to minus 2n pi minus pi by 2. Second case, taking negative signs. So x is equal to 2n pi minus pi by 2 plus 2x. So x comes out to be 2n pi by 3 minus pi by 6. Third question, cos x into cos x plus pi by 3 into cos pi by 3 minus x is equal to 1 by 4. We can switch these. Cos x into cos pi by 3 plus x into cos pi by 3 minus x is equal to 1 by 4. Now multiply by 2 and divide by 2. Cos x into 1 by 2 into 2 cos pi by 3 plus x into cos pi by 3 minus x is equal to 1 by 4. Now it is in the form 2 cos A cos B, that is equal to cos A plus B plus cos A minus B. Value of cos 2 pi by 3 is equal to minus 1 by 2. And cos 2x can be expanded as 2 cos square x minus 1. So minus 1 minus 1 by 2 will be minus 3 by 2 plus 2 cos square x. Take 1 by 2 outside. So it will be 1 by 4 cos x within brackets minus 3 plus 4 cos square x is equal to 1 by 4. Now push cos x inside. So it will be 1 by 4 minus 3 cos x plus 4 cos cube x. 4 cos cube x minus 3 cos x is equal to cos 3x. So 1 by 4 cos 3x is equal to 1 by 4 or cos 3x is equal to 1. Now it is in the form cos theta is equal to 1. So theta is equal to 2n pi is general solution. Here theta is 3x. So 3x is equal to 2n pi or x equal to 2n pi by 3. Third type, equations of the form sin square x is equal to sin square alpha, cos square x is equal to cos square alpha, tan square x is equal to tan square alpha. We will see two questions in this. First question, 7 cos square x plus 3 sin square x is equal to 4. Cos square x can be written as 1 minus sin square x. So it will be 7 minus 7 sin square x plus 3 sin square x is equal to 4. Or sin square x is equal to 3 by 4. 3 by 4 can be written as root 3 by 2 whole square. And root 3 by 2 is the value of sin 60 degrees or sin pi by 3. So sin square x is equal to sin square pi by 3. Now it is in the form sin square theta is equal to sin square alpha. And the general solution is given by theta is equal to n pi plus minus alpha. Here theta is equal to x and alpha is equal to pi by 3. So x is equal to n pi plus minus pi by 3. Second question, 81 to power sin square x plus 81 to power cos square x is equal to 30. X lies between 0 to pi. Cos square x can be written as 1 minus sin square x. 81 to power 1 minus sin square x can be split as 81 to power 1 into 81 to power minus sin square x. 81 to power minus sin square x can be written as 1 upon 81 to power sin square x. Now assume 81 to power sin square x is equal to t. So this can be written as t plus 81 by t is equal to 30, or t square plus 81 is equal to 30t, or t square minus 30t plus 81 is equal to 0. This can be factorized as t minus 3 into t minus 27 is equal to 0. So either t minus 3 is equal to 0 or t minus 27 is equal to 0. So we will consider two cases accordingly. When t minus 3 is equal to 0, that means t is equal to 3. So 81 to power sin square x is equal to 3. Write 81 as 3 to power 4. So 3 to power 4 to power sin square x is equal to 3. Now powers will be multiplied. So 3 to power 4 sin square x is equal to 3 to power 1. Now bases are same, so we can compare powers. So 4 sin square x is equal to 1, or sin square x is equal to 1 by 4. 1 by 4 can be written as 1 by 2 whole square. 1 by 2 is the value of sine 30 degrees. So sin square x is equal to sin square pi by 6. Now it is in the form sin square theta is equal to sin square alpha. So general solution is theta is equal to n pi plus minus alpha. Here theta is x and alpha is pi by 6. So x is equal to n pi plus minus pi by 6. Second case, when t minus 27 is equal to 0 or t is equal to 27. So 81 to power sin square x is equal to 27. Write 81 as 3 to power 4 and 27 as 3 to power 3. So bases are same, so you can compare powers. 4 sin square x is equal to 3, or sin square x is equal to 3 by 4. 3 by 4 can be written as root 3 by 2 whole square. Root 3 by 2 is the value of sine 60 degrees. So sin square x is equal to sin square pi by 3. Now it is in the form sin square theta is equal to sin square alpha, and the general solution is theta is equal to n pi plus minus alpha. Here theta is equal to x and alpha is equal to pi by 3. So x is equal to n pi plus minus pi by 3. Fourth question, equations of the form a cos x plus b sin x is equal to c, where a, b, c are real numbers and mod c is less than or equal to under root a square plus b square. First, we will reduce the equation to cos x is equal to cos alpha or sin x is equal to sin alpha. Put a is equal to r cos alpha and b is equal to r sin alpha in this equation. So r cos alpha cos x plus r sin alpha sin x is equal to c. Take r as common, so it will be cos alpha cos x plus sin alpha sin x in bracket is equal to c. Now this is in the form cos a cos b plus sin a sin b, that is cos a minus b. So it can be written as r cos x minus alpha is equal to c, or cos x minus alpha is equal to c by r. Let's say c by r is equal to cos theta. Now it is in the form cos theta is equal to cos alpha. So the general solution is theta is equal to 2n pi plus minus alpha. Here theta is x minus alpha and alpha is equal to beta. So general solution will be x is equal to 2n pi plus alpha plus minus beta. Let us see one question on type 4. Cot x plus cosec x is equal to root 3. Cot x can be written as cos x upon sin x. Cosec x can be written as 1 upon sin x. So it is cos x minus root 3 sin x is equal to minus 1. Now compare this equation with this. So a is equal to 1, b is equal to minus root 3 and c is equal to minus 1. In place of a, write r cos theta, and in place of b, write r sin theta. So 1 is equal to r cos theta and minus root 3 is equal to r sin theta. From these two equations, we can figure out r and theta. So r comes out to be plus minus 2. We will take only positive value and theta is equal to minus pi by 3. Now again in this equation, write r cos theta in place of A and r sin theta in place of B. So the equation becomes r cos x minus theta is equal to minus 1. As you take r common, then it becomes cos A cos B plus sin A sin B, that is cos A minus B. So the equation is now cos x minus theta is equal to minus 1 upon r. Substitute the value of theta as minus pi by 3 and r as 2. So equation becomes cos x plus pi by 3 is equal to minus 1 by 2. Minus 1 by 2 in cos form can be written as cos 2 pi by 3. Now it is cos theta is equal to cos alpha. So theta is equal to 2n pi plus minus alpha. Here theta is equal to x plus pi by 3 and alpha is 2 pi by 3. So x comes out to be 2n pi plus pi by 3 or x is equal to 2n minus 1 pi. Now let us see how to solve trigonometric inequalities with the help of this question. Find the solutions of sin x greater than or equal to 1 by 2. Sin x is equal to 1 by 2 at 2 points. X is equal to pi by 6 and x is equal to 5 pi by 6 between 0 to 2 pi. This is the graph of sin x. 1 by 2 value is achieved at 2 points P and Q, that is at x is equal to pi by 6 and at x is equal to 5 pi by 6. Now between P and Q, value is greater than or equal to 1 by 2 and less than or equal to 1. So solution set is x belongs to 2n pi plus pi by 6, 2n pi plus 5 pi by 6. This means x lies between these two extremes, including these two extreme values, where n is integer. Let us solve previous year's JEE questions. First question, if root 2 sin alpha upon root 1 plus cos 2 alpha is equal to 1 by 7 and root 1 minus cos 2 beta upon 2 is equal to 1 by root 10. Alpha beta lie between 0 to pi by 2. Then tan alpha plus 2 beta is equal to. This question appeared in JEE Mains 2020. It is given that root 2 sin alpha upon root 1 plus cos 2 alpha is equal to 1 by 7. We want to get rid of this under root. So we will expand cos 2 alpha as 2 cos square alpha minus 1, so that plus 1 and minus 1 get cancelled. So it will be under root 2 cos square alpha, which is equal to under root 2 into cos alpha. Now root 2 get cancelled. Sin alpha upon cos alpha is equal to tan alpha. So tan alpha is equal to 1 by 7. Make a right angle triangle, triangle ABC, in which angle B is equal to 90 degrees and angle A is equal to alpha. BC is equal to 1 and AB is equal to 7. So that tan alpha is equal to 1 by 7. Applying Pythagoras theorem in this, AC is equal to under root 50. Also, it is given that root 1 minus cos 2 beta upon 2 is equal to 1 by root 10. We want to get rid of this under root. So we will expand cos 2 beta as 1 minus 2 sin square beta, so that plus 1 and minus 1 get cancelled. So it will be 2 sin square beta upon 2. 2 get cancelled. Under root sin square beta will be sin beta. So sin beta is equal to 1 upon under root 10. Make a right angle triangle, triangle PQR, in which angle Q is 90 degrees and angle P is equal to beta. QR is equal to 1 and PR is equal to under root 10. So that sin beta is equal to 1 upon root 10. Applying Pythagoras theorem, PQ is equal to 3. Tan beta is equal to 1 by 3. Now tan 2 beta is equal to 2 tan beta upon 1 minus tan square beta. Putting the value of tan beta is equal to 1 by 3, tan 2 beta comes as 3 by 4. Value of tan 2 beta we will use here. Tan alpha plus 2 beta we have to calculate. Tan alpha plus 2 beta is equal to tan alpha plus tan 2 beta upon 1 minus tan alpha tan 2 beta. Putting the value of tan alpha from here and tan 2 beta from here, tan alpha plus 2 beta comes as 1. So the answer is 1. Second question, if x lies between 0 to pi by 2, then the number of values of x for which sin x minus sin 2x plus sin 3x is equal to 0 is. These are the options given. This question appeared in JEE Mains 2019. It is given that sin x minus sin 2x plus sin 3x is equal to 0. We can combine these two. Sin 3x plus sin x minus sin 2x is equal to 0. This is in the form sin c plus sin d, which is 2 sin c plus d by 2 cos c minus d by 2 minus sin 2x is equal to 0. 2 sin 2x cos x minus sin 2x is equal to 0. We can take sin 2x common in these two terms. So sin 2x into 2 cos x minus 1 is equal to 0. So either sin 2x is equal to 0 or 2 cos x minus 1 is equal to 0. So accordingly, we will consider two cases. First case, when sin 2x is equal to 0. We know that when sin theta is equal to 0, general solution is theta is equal to n pi. Here theta is 2x. So 2x is equal to n pi, or x is equal to n pi by 2. When you put n is equal to 0, x is equal to 0. When you put n is equal to 1, x is equal to pi by 2. So in this interval where 0 is included but pi by 2 is not included, that means only one solution is there, x is equal to 0. X is equal to pi by 2 is rejected. Second case, when 2 cos x minus 1 is equal to 0, or 2 cos x is equal to 1, or cos x is equal to 1 by 2, which can be written as cos pi by 3. So cos theta is equal to cos alpha gives the general solution as theta is equal to 2n pi plus minus alpha. Here theta is x and alpha is pi by 3. So general solution is x is equal to 2n pi plus minus pi by 3. Now in this interval, that is in first quadrant, where 0 is included but pi by 2 is not included, we can put n is equal to 0. So x is equal to pi by 3. So there is only one solution in this interval, x is equal to pi by 3. So total solutions are 2, one from here, one from here. So number of solutions are 2. Answer is option A. Third question, the maximum value of 3 cos theta plus 5 sin theta minus pi by 6 for any real value of theta is. These are the options given. This question appeared in JEE Mains 2019. Suppose the given expression is equal to A. Then slope of tangent at any point is given by dA upon d theta. At maxima or minima, dA upon d theta is equal to 0 because the tangent will be parallel to x-axis. So dA upon d theta is equal to 0 means 0 is equal to this. So this gives tan theta is equal to 5 root 3. Now make a right angle triangle, triangle ABC, in which angle B is 90 degrees and angle A is theta. BC is equal to 5 root 3, AB is equal to 1. So that tan theta is equal to 5 root 3 upon 1. Applying Pythagoras theorem, AC comes out to be under root 76. Now sin theta is equal to 5 root 3 upon root 76 and cos theta is equal to 1 upon root 76. Now let us simplify the given expression. So A is equal to 3 cos theta plus 5. This is sin A minus B, that is sin A cos B minus cos A sin B. So on simplification, A is equal to 3 cos theta plus 5 by 2 into root 3 sin theta minus cos theta. Put the value of sin theta and cos theta from here. Sin theta as 5 root 3 upon root 76 and cos theta as 1 upon root 76. So A max comes out to be under root 19. So the correct option is option A. Fourth question, the value of cos cube pi by 8 into cos 3 pi by 8 plus sin cube pi by 8 into sin 3 pi by 8 is. These are the options given. This question appeared in JEE Mains 2020. First term can be written as 2 cos A cos B if we split cos cube pi by 8 as cos square pi by 8 into cos pi by 8. Similarly, second term can be written as 2 sin A sin B if we split sin cube pi by 8 as sin square pi by 8 into sin pi by 8. Now, it can be written as 2 cos A cos B when we multiply by 2 and divide by 2. Similarly, this can be written as 2 sin A sin B if we multiply by 2 and divide by 2. So, 1 by 2 is taken as common. Now, it is 2 cos A cos B, which is equal to cos A plus B plus cos A minus B. And this is 2 sin A sin B, which means cos A minus B minus cos A plus B. Cos 4 pi by 8 is equal to cos pi by 2, which is equal to 0. Cos 2 pi by 8 is equal to cos pi by 4, which is equal to 1 by root 2. Cos 2 pi by 8 is equal to cos pi by 4, which is equal to 1 by root 2. And cos 4 pi by 8 is equal to cos pi by 2, which is equal to 0. 1 by root 2 is taken as common in both the terms. So, in bracket, it comes out to be cos square pi by 8 plus sin square pi by 8. And we know that cos square theta plus sin square theta is equal to 1. So, the value comes out to be 1 upon 2 root 2. So, the correct option is option C. Fifth question, if L is equal to sin square pi by 16 minus sin square pi by 8 and M is equal to cos square pi by 16 minus sin square pi by 8, then these are the options given. This question appeared in JEE Mains 2020. Look at the options. We have to simplify L and M. L is written in the form sin square A minus sin square B and M is written in the form cos square A minus sin square B. Recall the formula of sin square A minus sin square B is equal to sin A plus B into sin A minus B. So, L is equal to sin pi by 16 plus pi by 8 into sin pi by 16 minus pi by 8. Sin of minus theta is equal to minus sin theta. Now, this can be written as 2 sin A sin B by multiplying by 2 and dividing by 2. And 2 sin A sin B is equal to cos A minus B minus cos A plus B. Cos of minus theta is equal to cos theta. Value of cos pi by 4 is equal to 1 by root 2. So, L is equal to minus 1 by 2 cos pi by 8 plus 1 by 2 root 2. Let us try to match with one of these options. This can be matched with B or D, but it is not matching with any. So, we have to look out for another clue. M is written in the form cos square A minus sin square B. Recall the formula. Cos square A minus sin square B is equal to cos A plus B into cos A minus B. So, M is equal to cos pi by 16 plus pi by 8 into cos pi by 16 minus pi by 8. So, M is equal to cos 3 pi by 16 into cos minus pi by 16. Cos of minus theta is equal to cos theta. Now, this can be written as 2 cos A cos B by multiplying by 2 and dividing by 2. And 2 cos A cos B is equal to cos A plus B plus cos A minus B. Value of cos pi by 4 is equal to 1 by root 2. So, M comes out to be equal to 1 by 2 root 2 plus 1 by 2 cos pi by 8. Let us try to match with option A or option C. It matches with option A. So, A is the correct option. Sixth question, the value of cos square 10 degree minus cos 10 degree cos 50 degree plus cos square 50 degree is. These are the options given. This question appeared in JEE Mains 2019. By looking at the expression, we can guess that it can be written in the form a square plus b square minus 2ab, and that is a minus b whole square. So let us do that. Cos 50 degree minus cos 10 degree whole square plus cos 50 degree into cos 10 degree is equivalent to this. When this is expanded, it will be a square plus b square minus 2ab. But here it is minus ab. So we have to add ab. Now this is in the form cos c minus cos t, which is equal to 2 sin c plus d by 2 into sin d minus c by 2. And this can be written as 2 cos a cos b by multiplying by 2 and dividing by 2. So value of this comes as 2 sin 30 degree into sin minus 20 degree whole square plus 1 by 2 cos 60 degree plus cos 40 degree. Value of sin 30 degree is equal to 1 by 2. Sin of minus theta is equal to minus sin theta. Value of cos 60 degree is equal to 1 by 2, and cos 40 degree can be written as 1 minus 2 sin square 20 degree, so that it matches with first term. Now this comes as sin square 20 degree plus 3 by 4 minus sin square 20 degree. Now plus and minus of sin square 20 degree get cancelled. So answer is 3 by 4. Option B is correct. Seventh question, the number of solutions of the equation mod cot x is equal to cot x plus 1 by sin x in the interval 0 to 2 pi is. This question appeared in JEE Mains 2021. We have to think when cot x is positive and when cot x is negative. We know that in first and third quadrant, both tan and cot are positive. And in second and fourth quadrant, both tan and cot are negative. So accordingly, we will consider two cases. Case 1, when x is in first quadrant or in third quadrant, then mod cot x is equal to cot x. So cot x is equal to cot x plus 1 by sin x. Cot x get cancelled. So 0 is equal to 1 upon sin x, or sin x is equal to 1 upon 0, which is infinity. This is not possible as the maximum value of sin is equal to 1. So no solution in this case. Second case, when x is in second quadrant or fourth quadrant, then mod cot x is equal to minus cot x. So minus cot x is equal to cot x plus 1 by sin x. Cot x can be written as cos x upon sin x. So this gives cos x is equal to minus 1 by 2. We are considering that x can be either in second quadrant or fourth quadrant. Cos x is negative, so x cannot be in fourth quadrant because in fourth quadrant cos is positive. So x has to be in second quadrant, and we know that value minus 1 by 2 is that of cos 120 degrees, that is cos 2 pi by 3. So x is equal to 2 pi by 3 is the only solution. So number of solutions will be 1. Eighth question, if root 3 times cos square x is equal to root 3 minus 1 times cos x plus 1, the number of solutions of the given equation when x lies between 0 to pi by 2 is. This question appeared in JEE Mains 2021. It is given that root 3 cos square x is equal to root 3 minus 1 times cos x plus 1. Bring right hand side to left hand side. So it will be root 3 cos square x minus root 3 minus 1 times cos x minus 1 is equal to 0. This is a quadratic equation in cos x. Compare with ax square plus bx plus c is equal to 0. So a is equal to root 3, b is equal to minus times root 3 minus 1, and c is equal to minus 1. So cos x is equal to minus b plus minus under root b square minus 4ac upon 2a. So in third step, it comes out to be root 3 minus 1 plus minus under root 4 plus 2 root 3 upon 2 root 3. 4 plus 2 root 3 is equal to root 3 plus 1 whole square. So we will get rid of this under root, and this comes out to be root 3 minus 1 plus minus under root 3 plus 1 upon 2 root 3. We will consider two cases. First, while taking positive value, and second, while taking negative value. So while taking positive value, cos x is equal to root 3 minus 1 plus root 3 plus 1 upon 2 root 3. That means cos x is equal to 1. And we know that cos 0 is equal to 1 in first quadrant. We have to consider while x is in first quadrant. So this will give one solution because 0 can be included. Second case, while taking negative value. So cos x is equal to root 3 minus 1 minus root 3 minus 1 upon 2 root 3. That gives cos x is equal to minus 1 by root 3. This cannot be taken because in first quadrant all trigonometric ratios are positive including cos. So in first quadrant cos cannot be negative. So there is only one solution. So number of solutions in this case will be 1. Ninth question, the number of integral values of k for which the equation 3 sin x plus 4 cos x is equal to k plus 1 has a solution k is real is. This question appeared in JEE Mains 2021. The given equation is 3 sin x plus 4 cos x is equal to k plus 1 or 4 cos x plus 3 sin x is equal to k plus 1. Compare it with a cos theta plus b sin theta is equal to c. So a is equal to 4, b is equal to 3 and c is equal to k plus 1. Now write a is equal to r cos theta and b is equal to r sin theta. So 4 is equal to r cos theta and 3 is equal to r sin theta. Now solving these two equations for r and theta gives r is equal to plus minus 5 and tan theta is equal to 3 by 4. Now put a is equal to r cos theta and b is equal to r sin theta in this equation. So this equation becomes r cos theta cos x plus r sin theta sin x is equal to k plus 1. Take r common in these two terms. So it becomes r in bracket cos theta cos x plus sin theta sin x, and that is cos theta minus x. So r cos theta minus x is equal to k plus 1 or cos theta minus x is equal to k plus 1 by r. Put the value of r as 5. So cos theta minus x is equal to k plus 1 by 5. Now let's say theta minus x is alpha. So cos alpha is equal to k plus 1 by 5. We know that cos alpha lies between minus 1 to plus 1. So k plus 1 by 5 will also lie between minus 1 to plus 1. Now we can solve this inequality by saying k plus 1 by 5 is greater than or equal to minus 1 and k plus 1 by 5 is less than or equal to 1. So k is greater than or equal to minus 6 and k is less than or equal to plus 4. So integral values of k will be minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. So total 11 values. So the answer is the number of integral values of k will be 11. 10th question, let AD and BC be two vertical poles at A and B respectively on a horizontal ground. If AD is equal to 8 meter, BC is equal to 11 meter and AB is equal to 10 meter, then the distance in meters of a point M on AB from point A such that MD square plus MC square is minimum is. This question appeared in JEE Mains 2020. It is given that there are two poles BC and AD. Height of BC is 11 meter and height of AD is 8 meter. Distance between them, that is AB, is 10 meter. We have to find a point M on AB such that MD square plus MC square is minimum. Let's assume AM is equal to x meter. So MB is equal to 10 minus x meter. Applying Pythagoras theorem in this triangle, MD square is equal to 8 square plus x square. Applying Pythagoras theorem in this triangle, MC square is equal to 10 minus x whole square plus 11 square. So we will get two equations. Now MD square plus MC square is represented by A. So A is equal to 185 plus x square plus 10 minus x whole square. Now at maximum or minimum point, slope of tangent will be equal to 0. And slope of tangent is given by dA by dx. So we will find out dA by dx and equate that to 0. So 0 is equal to 4x minus 20 or x is equal to 5 meter. So that is our answer. 11th question. Two vertical poles AB is equal to 15 meter and CD is equal to 10 meter are standing apart on a horizontal ground with points A and C on the ground. If P is the point of intersection of BC and AD, then the height of P in meter above the line AC is. These are the options given. This question appeared in JEE Mains 2020. It is given that there are two poles AB and CD. Height of pole AB is 15 meters and height of pole CD is 10 meters. Point of intersection of DA and BC is P. We have to calculate the height of P, that is PQ. Let's say PQ is H meters. Triangle PCQ and triangle BCA are similar triangles. We can prove that. Angle PCQ is equal to angle BCA. Both are same angles. Angle PQC is equal to angle BAC. Both are right angles. PQ is parallel to BA and BC is transversal. So angle CPQ is equal to angle CBA. So corresponding angles are same. That means these two triangles are similar triangles. So we will use the property of similar triangles that the corresponding sides are in equal ratio. That means PQ upon BA is equal to CQ upon CA. PQ is H meter, BA is given as 15 meter. So H upon 15 is equal to CQ upon CA. This is our first equation. Similarly, triangle PAQ and triangle DAC are similar triangles. So PQ upon DC is equal to AQ upon AC. AQ we can write as AC minus CQ. So H upon 10 is equal to CA minus CQ upon CA. This we can write as 1 minus CQ upon CA. Value of CQ upon CA we can put from equation 1. So it becomes H by 10 is equal to 1 minus H by 15. Solving this gives H is equal to 6 meter and that is our answer. So correct option is option D. Last question. The angle of elevation of the top of a hill from a point on the horizontal plane passing through the foot of the hill is found to be 45 degrees. After walking a distance of 80 meters towards the top, up a slope incline at an angle of 30 degrees to the horizontal plane, the angle of elevation of the hill becomes 75 degrees. Then the height of the hill in meters is. This question appeared in JEE Mains 2020. QP is the hill. Angle of elevation of Q from a point R on the ground is 45 degrees. RS is given as 80 meters. RS makes an angle of 30 degree with the horizontal. Angle of elevation of Q from point S is given as 75 degrees. Then we have to calculate QP. In right angle triangle, triangle QRP, tan 45 is equal to QP upon RP. Value of tan 45 is 1. So 1 is equal to QP upon RP. That is QP is equal to RP. This is our first equation. In right angle triangle SRU, SU is equal to RS sin 30 and RU is equal to RS cos 30. So SU is equal to RS is given as 80, value of sin 30 is 1 by 2, RS is given as 80, value of cos 30 is equal to root 3 by 2. So SU is equal to 40 meter and RU is equal to 40 root 3 meter. Now SU is equal to TP. So TP is equal to 40 meter. This is our second equation. UP is equal to RP minus RU and RP is equal to QP and RU is equal to 40 root 3. So UP is equal to QP minus 40 root 3. UP is equal to ST. So ST is equal to QP minus 40 root 3. This is our third equation. QT is equal to QP minus TP. So QT is equal to QP minus TP is equal to 40 meter. So QT is equal to QP minus 40. This is our fourth equation. In right angle triangle, triangle QST, tan 75 degree is equal to QT upon ST. Value of QT is QP minus 40 and value of ST is equal to QP minus 40 root 3. Value of tan 75 degree we know is root 3 plus 1 upon root 3 minus 1. So QP comes out to be 80 meter and that is our answer. Let us solve few more JEE questions. First question, if sine theta plus cos theta is equal to 1 by 2, then 16 times sine 2 theta plus cos 4 theta plus sine 6 theta is equal to. These are the options given. This question appeared in JEE Mains 2021. We have to get the value of this expression. That means we have to get the value of sine 2 theta, cos 4 theta and sine 6 theta. The value of sine 2 theta we can get from here. So square both the sides of this equation. Sine theta plus cos theta whole square is equal to 1 by 2 square. This can be expanded as sine square theta plus cos square theta plus 2 sine theta cos theta is equal to 1 by 4. Sine square theta plus cos square theta is equal to 1 and 2 sine theta cos theta is equal to sine 2 theta. So the value of sine 2 theta is equal to minus 3 by 4. This is first equation. Next, we have to get the value of cos 4 theta. So cos 4 theta is equal to 1 minus 2 sine square 2 theta. Value of sine 2 theta we can put from here. So cos 4 theta comes out to be equal to minus 1 by 8. This is second equation. Next, we have to get the value of sine 6 theta. Sine 6 theta can be written as sine 3 times of 2 theta. Let's say alpha is equal to 2 theta. So sine 3 alpha is equal to 3 sine alpha minus 4 sine cube alpha. Value of sine 2 theta we can put from here. So sine 6 theta comes out to be equal to minus 9 by 16. Now we can get the value of this expression by putting the value of sine 2 theta from here, cos 4 theta from here and sine 6 theta from here. So value of the expression comes out to be equal to minus 23. So the correct option is option C. Second question, the number of solutions of the equation 32 to power tan square x plus 32 to power sec square x is equal to 81 when x lies between 0 to pi by 4 is. These are the options given. This question appeared in JEE Mains 2021. The given equation is 32 to power tan square x plus 32 to power sec square x is equal to 81. We can write sec square x as 1 plus tan square x. Now we can split 32 to power 1 plus tan square x as 32 to power 1 into 32 to power tan square x. Now assume 32 to power tan square x is equal to t. So this equation becomes t plus 32t minus 81 is equal to 0 or 33t is equal to 81 or t is equal to 81 by 33 or t is equal to 27 by 11. It means 32 to power tan square x is equal to 27 by 11. We can write 32 as 2 to power 5. So it becomes 2 to power 5 to power tan square x is equal to 27 by 11. Powers can be multiplied. So 2 to power 5 tan square x is equal to 27 by 11. Now take log on both the sides at base 2. So it becomes 5 tan square x log 2 base 2 is equal to log 27 by 11 to the base 2. Value of log 2 base 2 is equal to 1 and value of 27 by 11 is approximately 2.46. So it becomes 5 tan square x is equal to log 2.46 to the base 2 or tan square x is equal to 1 by 5 log 2.46 to the base 2, or tan x is equal to plus minus under root 1 by 5 log 2.46 to the base 2. Now, tan x cannot be negative in the given interval when x lies between 0 to pi by 4, that is in first quadrant. So, tan x will be positive. So, there is only one solution in this case. So, number of solutions of the given equation will be 1. Third question, if for x belongs to 0 to pi by 2, log sin x to the base 10 plus log cos x to the base 10 is equal to minus 1, and log sin x plus cos x to the base 10 is equal to 1 by 2 times log n to the base 10 minus 1. N is greater than 0. Then the value of n is equal to. These are the options given. This question appeared in JEE Mains 2021. First equation is given as log sin x to the base 10 plus log cos x to the base 10 is equal to minus 1. We know that log m to the base a plus log n to the base a is equal to log mn to the base a. So it becomes log sin x into cos x to the base 10 is equal to minus 1. This can be written as sin x into cos x is equal to 10 to power minus 1. 10 to power minus 1 is equal to 1 by 10. So sin x cos x is equal to 1 by 10. This is our first equation. Second equation is given as log sin x plus cos x to the base 10 is equal to 1 by 2 times log n to the base 10 minus 1. Now objective here is to make the bases same on the both sides so that we can compare the expressions. Bring 2 on this side. So it becomes 2 log sin x plus cos x to the base 10 is equal to log n to the base 10 minus 1 can be written as log 10 to the base 10. 2 can be shifted here as power. So it becomes log sin x plus cos x whole square to the base 10 is equal to. Now log m to the base a minus log n to the base a is equal to log m by n to the base a. So it is log n by 10 to the base 10. Now bases are same on both the sides. So we can compare expressions. So sin x plus cos x whole square is equal to n by 10. This can be expanded as sin square x plus cos square x plus 2 sin x cos x, and that is equal to n by 10. Sin square x plus cos square x is equal to 1, and value of sin x cos x can be put from here. So n comes out to be equal to 12. So the correct option is option B. Fourth question, if x and y lie between 0 and pi and cos x plus cos y minus cos x plus y is equal to 3 by 2, then sin x plus cos y is equal to. These are the options given. This question appeared in JEE Mains 2021. The given equation is cos x plus cos y minus cos x plus y is equal to 3 by 2. Cos x plus cos y can be written as 2 cos x plus y by 2 cos x minus y by 2, and cos x plus y can be written as 2 cos square x plus y by 2 minus 1. So it becomes a quadratic equation in cos x plus y by 2. Now put cos x plus y by 2 is equal to t. So the equation becomes 2t square minus 2t into cos x minus y by 2 plus 1 by 2 is equal to 0. Now compare it with ax square plus bx plus c is equal to 0. So a is equal to 2, b is equal to minus 2 cos x minus y by 2, and c is equal to 1 by 2. Now the discriminant b square minus 4ac should be greater than or equal to 0. Putting the values of a, b and c, it comes out to be cos square x minus y by 2 is greater than or equal to 1. Value of cos cannot be greater than 1. So it has to be equal to 1. So cos square x minus y by 2 is equal to 1. 1 is the value of cos 0. So x minus y by 2 is equal to 0, or x is equal to y. Put this value in this equation. So this equation becomes now cos x plus cos x minus cos x plus x is equal to 3 by 2. Or 2 cos x minus cos 2x is equal to 3 by 2. Cos 2x can be written as 2 cos square x minus 1. So it reduces to 4 cos square x minus 4 cos x plus 1 is equal to 0. Now this is whole square of 2 cos x minus 1. So 2 cos x minus 1 is equal to 0, or cos x is equal to 1 by 2. 1 by 2 is the value of cos 60 degrees in 0 to pi. So x is equal to pi by 3. Now x is equal to y and x is equal to pi by 3. So y is also pi by 3. So sin x plus cos y is equal to sin pi by 3 plus cos pi by 3. Value of sin pi by 3 is equal to root 3 by 2 and value of cos pi by 3 is equal to 1 by 2. So the answer is root 3 plus 1 by 2. Option B is correct. Fifth question, let S be the set of all theta where theta lies between minus 2 pi to 2 pi such that 2 cos square theta plus 3 sin theta is equal to 0. Then the sum of the elements of S is. These are the options given. This question appeared in JEE Mains 2019. The given equation is 2 cos square theta plus 3 sin theta is equal to 0. Cos square theta can be written as 1 minus sin square theta. So this becomes a quadratic equation in sin theta, and the equation is 2 sin square theta minus 3 sin theta minus 2 is equal to 0, which can be factorized as 2 sin theta plus 1 into sin theta minus 2 is equal to 0. That means either 2 sin theta plus 1 is equal to 0 or sin theta minus 2 is equal to 0. So we will consider two cases. Case 1, when 2 sin theta plus 1 is equal to 0 or sin theta is equal to minus 1 by 2. We know that sin theta is negative in third and fourth quadrants. We will split this interval minus 2 pi to 2 pi into two subintervals, minus 2 pi to 0 and 0 to 2 pi. In interval minus 2 pi to 0, angles will be negative. Angles are negative when they are measured clockwise starting from 0. So in this interval, angles will be minus 150 degree and minus 30 degree, which satisfy this criteria. Similarly, in interval 0 to 2 pi, angles will be plus 210 degree and plus 330 degrees. Angles are positive when they are measured anti-clockwise starting from 0. Case 2, when sin theta minus 2 is equal to 0. So sin theta is equal to 2, which is not possible because we know the maximum value of sin theta is equal to 1. So no solution in this case. So finally, sum of the elements of S will be sum of these four angles, which is equal to 360 degrees or 2 pi. So the answer is 2 pi. Option C is correct. Sixth question, the number of solutions of the equation x plus 2 tan x is equal to pi by 2 in the interval 0 to 2 pi is. These are the options given. This question appeared in JEE Mains 2021. The given equation is x plus 2 tan x is equal to pi by 2, or 2 tan x is equal to minus x plus pi by 2, or tan x is equal to minus 1 by 2x plus pi by 4. This cannot be simplified further using any trigonometric formula. So we need to find a way to move ahead. Let us say y is equal to tan x is equal to minus 1 by 2x plus pi by 4. Y is equal to minus x by 2 plus pi by 4 is the equation of a straight line which is in the form y is equal to mx plus c, where m is its slope and c is its y-intercept. M is equal to minus 1 by 2 and c is equal to pi by 4. Negative slope suggests that this line makes an angle more than 90 degrees with the positive x-axis. So PQ is that line which is making more than 90 degrees with the positive x-axis and its y-intercept is pi by 4. Y is equal to tan x is this curve. So solution of this equation will be points of intersection of these two curves. So points of intersection between x is equal to 0 to x is equal to 2 pi in the given interval are marked by points A, B and C. So there will be 3 solutions. So the correct option is option A. Seventh question, the number of solutions of sine to power 7x plus cos to power 7x is equal to 1. X lies between 0 to 4 pi is equal to. These are the options given. This question appeared in JEE Mains 2021. The given equation is sine to power 7x plus cos to power 7x is equal to 1. We know that maximum value of sin x or cos x is equal to 1. We also know that sin square x plus cos square x is equal to 1. If it is sin cube x plus cos cube x, it will be less than 1. For example, let's say sin x is equal to 1 by 2. So sin square x is equal to 1 by 4 and sin cube x is equal to 1 by 8. That means when power is increasing, its value is decreasing. So applying the same logic, we can say that sin to power 7x plus cos to power 7x will be less than 1. But it is given that sin to power 7x plus cos to power 7x is equal to 1. That means one of them is 1 and another is 0. So we will consider two cases, when sin x is equal to 1 and cos x is equal to 0, and when sin x is equal to 0 and cos x is equal to 1. So in first case, solutions in the interval 0 to 4 pi will be pi by 2 and 5 pi by 2. In second case, solutions in the given interval will be 0, 2 pi and 4 pi. So there will be 2 plus 3, 5 solutions in total. So option C is correct. Eighth question, all the pairs x, y that satisfy the inequality 2 to power under root sin square x minus 2 sin x plus 5 into 1 by 4 to power sin square y is less than or equal to 1 also satisfies the equation. These are the options given. This question appeared in JEE Mains 2019. The given inequality is 2 to power under root sin square x minus 2 sin x plus 5 into 1 by 4 to power sin square y is less than or equal to 1. 4 can be written as 2 to power 2. Now powers can be multiplied. When you cross multiply, you will get 2 to power under root sin square x minus 2 sin x plus 5 is less than or equal to 2 to power 2 sin square y. Now bases are same. So we can write this inequality as under root sin square x minus 2 sin x plus 5 is less than or equal to 2 sin square y. This can be written as this. Under root sin x minus 1 whole square plus 4 is less than or equal to 2 sin square y. Now we will figure out minimum and maximum values of LHS and RHS. First, LHS. When sin x is equal to minus 1, LHS will have value 2 root 2. When sin x is equal to plus 1, LHS will have value 2. So LHS lies between 2 and 2 root 2. This is shown on the number line. Now RHS. When sin y is equal to 0, RHS will have value 0. And when sin y is equal to plus 1 or minus 1, RHS will have value 2. So RHS lies between 0 and 2. This is shown on the number line. Now this inequality holds true only when LHS is equal to RHS and their value is equal to 2. So we will equate LHS is equal to RHS is equal to 2. Now we will form two equations. Under root sin x minus 1 whole square plus 4 is equal to 2 and 2 sin square y is equal to 2. So first equation we will get sin x is equal to 1 and second we will get sin y is equal to plus minus 1. So from first and second equation we can say that sin x is equal to mod sin y. So option A is correct. Ninth question, let S be the sum of all solutions in radians of the equation sin to power 4 theta plus cos to power 4 theta minus sin theta cos theta is equal to 0 in interval 0 to 4 pi, then 8s upon pi is equal to. This question appeared in JEE Mains 2021. The given equation is sin to power 4 theta plus cos to power 4 theta minus sin theta cos theta is equal to 0. Sin square theta plus cos square theta whole square is equal to Sine to power 4 theta plus cos to power 4 theta plus 2 sine square theta cos square theta. Sine square theta plus cos square theta is equal to 1. So sine to power 4 theta plus cos to power 4 theta is equal to 1 minus 2 sine square theta cos square theta. This is first equation. Now the given equation is sine to power 4 theta plus cos to power 4 theta minus sine theta cos theta is equal to 0. We can put the value of sine to power 4 theta plus cos to power 4 theta from this equation. So the equation changes to 1 minus 2 sine square theta cos square theta minus sine theta cos theta is equal to 0, or 2 sine square theta cos square theta plus sine theta cos theta minus 1 is equal to 0. Now this becomes a quadratic equation in sine theta cos theta. So put sine theta cos theta is equal to t. So equation changes to 2t square plus t minus 1 is equal to 0. This can be factorized as 2t minus 1 into t plus 1 is equal to 0. So either 2t minus 1 is equal to 0 or t plus 1 is equal to 0. So we will consider two cases. Case 1, when 2t minus 1 is equal to 0 or t is equal to 1 by 2. T is equal to sine theta cos theta. So sine theta cos theta is equal to 1 by 2, or 2 sine theta cos theta is equal to 2 into 1 by 2. 2 sine theta cos theta is equal to sine 2 theta. Sine 2 theta is equal to 1. 1 is the value of sine pi by 2. Now this is in the form sine theta is equal to sine alpha. So the general solution is theta is equal to n pi plus minus 1 to power n alpha. So 2 theta is equal to n pi plus minus 1 to power n pi by 2, or theta is equal to n pi by 2 plus minus 1 to power n pi by 4, where n is integer. Now we will put the values of n as 0, 1, 2, 3, 4 and so on. When n is equal to 0, theta is pi by 4. When n is equal to 1, theta is equal to pi by 4. When n is equal to 2, theta is equal to 5 pi by 4. When n is equal to 3, theta is equal to 5 pi by 4. When n is equal to 4, theta is equal to 9 pi by 4. So the pattern is theta is equal to pi by 4, 5 pi by 4, 9 pi by 4, 13 pi by 4 and 17 pi by 4. 17 pi by 4 will be out of range, will be more than 4 pi. So we will consider only 4 solutions: pi by 4, 5 pi by 4, 9 pi by 4 and 13 pi by 4. Case 2, when t plus 1 is equal to 0 or t is equal to minus 1, t is equal to sine theta cos theta. So sine theta cos theta is equal to minus 1, or 2 sine theta cos theta is equal to minus 2. 2 sine theta cos theta is equal to sine 2 theta. So sine 2 theta is equal to minus 2, which is not possible because the minimum value of sine theta is equal to minus 1. So no solution in this case. Now S will be equal to summation of all these angles. So S comes out to be 7 pi. We have to calculate the value of 8S upon pi. So 8S upon pi is equal to 8 by pi into S, and S is 7 pi. So the answer is 56. So we will fill 56 here. Last question. Let f be a function from 0 to 2 interval to real number set defined by fx is equal to 3 minus sine 2 pi x into sine pi x minus pi by 4 minus sine 3 pi x plus pi by 4. If alpha beta belong to interval 0 to 2 are such that x belongs to 0, 2, fx is greater than or equal to 0 is equal to alpha, beta, then the value of beta minus alpha is. This question appeared in JEE Advanced 2020. The given function is 3 minus sine 2 pi x into sine pi x minus pi by 4 minus sine 3 pi x plus pi by 4, and this is greater than or equal to 0. We have to simplify this function first. So we will expand sine 2 theta as 2 sine theta cos theta, sine a minus b as sine a cos b minus cos a sine b, sine a plus b as sine a cos b plus cos a sine b. So this reduces to 1 by root 2 times sine pi x minus cos pi x into sine 2 pi x plus 4 is greater than or equal to 0. Finally, the inequality reduces to sine pi x minus pi by 4 into sine 2 pi x plus 4 is greater than or equal to 0. That means either both are positive or both are negative. So we will consider two cases. Case 1, when both are positive. Sin pi x minus pi by 4 is greater than or equal to 0. We know that sin theta is positive in first and second quadrants. So pi x minus pi by 4 will lie between 0 and pi. This gives x is greater than or equal to 1 by 4 and x is less than or equal to 5 by 4. Sin 2 pi x plus 4 is greater than or equal to 0, or sin 2 pi x is greater than or equal to minus 4. We know that sin theta is greater than or equal to minus 1. So this is true, but this will not give any solution. Second case, when both are negative. Sin pi x minus pi by 4 is less than or equal to 0. We know that sin theta is negative in third and fourth quadrants. So pi x minus pi by 4 will lie between pi and 2 pi. This gives x is greater than or equal to 5 by 4 and x is less than or equal to 9 by 4. Sin 2 pi x plus 4 is less than or equal to 0. That means sin 2 pi x is less than or equal to minus 4, which is not true, as we know that sin theta is greater than or equal to minus 1. So this will not give any solution. Finally, we need to combine these four solutions. X is less than or equal to 5 by 4 and x is greater than or equal to 5 by 4 will be true when x is equal to 5 by 4. So alpha will be 1 by 4 and beta will be 5 by 4. So beta minus alpha is equal to 5 by 4 minus 1 by 4, or beta minus alpha is equal to 1. So our answer is 1. In next video, we will start third chapter, that is quadratic equations. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.